Hello everyone, I am Dr. Avinashwali, Assistant Professor from the Department of ECE at SRM IST Katangalathu. Welcome to the session on cloud security. Today we are going to discuss how security is maintained in cloud computing environments and what kind of threats affect cloud systems. Nowadays, almost everything is connected to the cloud. For example, Gmail, Google Drive, online banking, social media, video streaming platforms, and even business applications. Since huge amounts of personal and organizational data are stored online, security becomes extremely important. For example, what happens if hackers steal user data? Or what if cloud servers crash due to attacks? Or how do companies protect millions of users at the same time? All these questions comes under cloud security. In this video, we will discuss in detail about cloud security risk, common attacks, authentication mechanisms, encryption techniques, and virtualization security. I will explain these concepts in a simple manner with examples so that you can easily understand them. So let us begin. Now let us see the topics covered in this unit. First, we will discuss cloud security risk and understand the major problems faced in cloud environments. Then we will be moving on to threat agents, then cloud security threats, cloud security mechanisms. Then we will be discussing about the authentication methods like Kerberos and one-time password systems. Finally, we will be studying about virtualization security, including virtual machine-based threats, hypervisor attacks, and trusted virtual machine monitors. So overall, this unit helps us to understand both cloud attacks and the mechanisms used to defend against them. This unit mainly refers to the textbook Cloud Computing Theory and Practice by Dan C. Marinesu. From this book, we will be specifically studying Chapter 11, which focuses on cloud security risk. It explains the different threats, attacks, and cloud security challenges present in cloud computing environments. Now, let us discuss some major cloud security risks. The first category is traditional security threats. These include attacks like distributed denial of service or DDoS attacks, phishing attacks, SQL injection, and cross-site scripting attacks. For example, in a phishing attack, users may receive fake emails asking them to enter banking passwords or login credentials. Similarly, in denial of service attack, attackers overload cloud servers with huge traffic, making services unavailable to the users. The next category is user and access risk. Weak passwords, compromised credentials, and poor key management can allow attackers to gain unauthorized access to cloud accounts and services. Another important risk is related to multi-tenancy and virtualization. Since multiple users share the same cloud infrastructure, vulnerabilities in hypervisors or virtual machines may affect several users together. Cloud systems also face difficulties in digital forensics because resources are distributed and dynamic. Now, let us continue with some additional security risk. The first category here is data security risk. These include data breaches, data leakage, and permanent data loss due to storage failures. For example, if confidential customer information stored in the cloud gets exposed to unauthorized users, it results in a data breach. The next are availability risk. Cloud services must remain available continuously, but failures such as power outages, denial of service attacks may cause downtime. So imagine an online payment application becoming unavailable during peak hours. This directly affects the users and the businesses. And the final category is third-party control risk. In cloud computing, users often do not have full control over the infrastructure because cloud providers manage the hardware and services. So lack of transparency from providers or vulnerabilities from subcontractors can also introduce security concerns. This slide shows some important threats identified by the Cloud Security Alliance, commonly called CSA. These threats include insecure APIs, malicious insiders, shared technology vulnerabilities, abuse of cloud services, and advanced persistent threats or APTs. For example, insecure APIs may allow attackers to access cloud services improperly if authentication mechanisms are weak. Malicious insiders are also dangerous because employees with administrative access may misuse privileges unintentionally. To protect cloud environments from these threats, organizations use several security measures such as multi-factor authentication, encryption, secure APIs, logging and monitoring, regular patch updates, and vulnerability management. These security practices help improve the confidentiality, integrity, and availability of cloud systems. In this unit, concepts are taken from the reference book Cloud Computing Concepts, Technology and Architecture by Thomas Earl, Pearson publication. So from this book, we will be covering chapter 6 and 10 based on fundamental cloud security and cloud security mechanisms. Before moving on to cloud attacks and security mechanisms, let us first understand some basic security terms and concepts. These concepts form the foundation of cloud security and help us understand how cloud systems protect data, users, and services from different threats and attacks. Let us discuss the first important security concept called confidentiality. Confidentiality means protecting data from unauthorized access. In simple words, only authorized users should be able to view or access the information. For example, consider a Gmail account. Only you should be able to read your emails. If someone else accesses them without permission, confidentiality is violated. Similarly, in cloud computing, users store sensitive information such as personal files, banking details, company documents, and medical records. So, cloud providers must ensure that this information is accessible only to authorized users. Now, look at the diagram shown here. The figure represents the data is securely transmitted between the user and the cloud using protected communication methods. You can compare confidentiality to sending a letter inside a locked envelope. Even if someone sees the envelope during transmission, they should not be able to read the contents inside. In cloud system, encryption is commonly used to maintain confidentiality. Let us discuss integrity. Integrity means ensuring that data is not altered or modified by unauthorized users. The main question here is the received data exactly the same as the original data? For example, suppose you transfer 10,000 through online banking. If an attacker changes the amount during transmission to 50,000, then data integrity is compromised. Now look at the diagram. It represents that data sent by the user should reach the cloud service without any modification during transmission or storage. A simple analogy for integrity is writing answers in an examination paper. If someone changes your answers after submission, the integrity of the document is lost. In cloud computing, hashing and digital signatures are commonly used to verify integrity and detect tampering. Now, let us discuss another important security concept called authenticity. Authenticity means verifying that the data or message actually comes from a genuine and authorized source. In simple words, it answers the question, can we trust the sender? For example, when you receive a message from your bank, you should be able to confirm that it is truly sent by the bank and not by a fake attacker. This slide also mentions about non-repudiation. This means that the sender cannot later deny sending the message. For example, a signature on an official document. The signature helps verify who actually signed it. Similarly, in cloud computing, digital signatures and authentication mechanisms help establish authenticity. Next is availability. Availability means cloud services and data should be accessible whenever users need them. For example, imagine an online shopping website during a festival sale. If the server crashes and users cannot access the website, availability is affected. In cloud computing, maintaining availability is very important because users expect services to work 24/7. Cloud providers use techniques such as backup systems, redundant servers, load balancing, and disaster recovery mechanisms to ensure continuous service availability. Now, let us understand three very important terms: threat, vulnerability, and risk. A threat is any possible danger that can cause harm to a system, whereas a vulnerability is a weakness in the system that attackers can exploit. Risk is the possibility of loss when a threat exploits a vulnerability. For example, suppose a user keeps a very weak password like 12345. Here, the hacker is the threat, the weak password is the vulnerability, and unauthorized account access is the risk. So, these three terms are closely connected in cloud security. Now, let us discuss three important concepts in cloud security. First, security controls are basically protective measures used to prevent attacks or reduce risk. For example, firewalls, antivirus software, authentication systems, and access control methods are all examples of security controls. Their main purpose is to protect sensitive data and cloud resources from threats. Next is security mechanisms. Security mechanisms are the actual technical methods or tools used to implement protection. For example, encryption, hashing, digital signatures, and intrusion detection systems are security mechanisms. You can think of security control as well as the overall protection strategy, while security mechanisms are the technologies used to achieve that protection. Finally, security policies are a set of rules and guidelines followed by an organization to maintain security. For example, a company policy may state passwords must contain special characters, users should change passwords every 90 days, or only authorized employees can access certain cloud resources. So, security policies define what should be done, while security controls and mechanisms help enforce those rules. Now, let us move to an important topic called threat agents. A threat agent is any entity that can cause harm to a cloud system by launching an attack. Threat agents may be external hackers, malicious insiders, unauthorized users, or even malicious software programs. In cloud computing, attacks can originate either internally or externally. Now, let us understand the diagram shown in this slide. At the center, you can see the cloud service consumer and the cloud provider environment. The diagram basically explains the relationship between threat agents, vulnerabilities, threats, risk, and security protections. First, let us start with vulnerabilities. A vulnerability is a weakness present in the system. For example, weak passwords, outdated software, or poor access control. Now, threat agents try to exploit these vulnerabilities. For example, suppose an attacker finds a weak password in a cloud account, that weakness becomes an entry point for attack. When the attacker actually attempts to exploit the vulnerability, it becomes a threat. If the threat succeeds, it creates risk, meaning possible damage such as data theft, service disruption, or unauthorized access. Now look at the protective side of the diagram. To defend against attacks, organizations implement security policies and security mechanisms. So security policies defines the rules and regulations, whereas security mechanisms are the actual protective technologies such as encryption, firewalls, authentication systems, and intrusion detection systems. So overall, this diagram explains how vulnerabilities create opportunities, threat agents exploit them, attacks generate risk, and security controls help protect the cloud environment. This forms the basic foundation for understanding cloud security threats. Now, let us discuss the first type of threat agent called an anonymous attacker. This attacker is basically an outsider who has no authorized access to the cloud environment but still tries to enter or attack the system. For example, imagine a person standing outside a company building and continuously trying different methods to enter the premises. Since they are not an employee, they may try tricks like using fake IDs, guessing passwords, or misleading security staff. Similarly, in cloud computing, anonymous attackers operate from outside the network and try methods such as password cracking, phishing attacks, bypassing authentication, or network level attacks. Because they are external attackers, they usually do not know the complete internal structure of the cloud system. So they depend on exploiting weak passwords, user mistakes, or security loopholes. These attackers often try to remain hidden and anonymous, making tracing and identification difficult. Next, let us discuss the malicious service agent. This is a very dangerous type of threat agent because it acts in between the user and the cloud service. Imagine you are sending an important confidential document through a courier service. While the document is traveling, suppose someone secretly opens the package, reads the contents, maybe changes some information, and then forwards it to the destination without your knowledge. That is exactly how a malicious service agent behaves. In cloud communication, data continuously travels between users and cloud servers. A malicious service agent secretly intercepts this communication. The attacker may observe the transmitted data, steal confidential information, modify messages, or even insert harmful content before forwarding it. The dangerous part is that both the sender and receiver may think communication is happening normally, while actually the data is being monitored or manipulated in between. This type of attack mainly affects confidentiality and integrity of cloud communication. Next, trusted attackers are quite different from anonymous attackers. Here, the attacker is not an outsider. The attacker is already inside the cloud environment with valid access permissions. That is why this type of attack becomes more dangerous. Think about a large apartment complex. Usually, security guards carefully watch strangers entering the building. But residents living inside can move freely because they are trusted. Now imagine one resident itself starts causing problems inside the apartment, maybe accessing other people's belongings or damaging shared facilities. Detecting such a person becomes difficult because nobody initially suspects them. Exactly the same thing happens in cloud computing. A trusted attacker is usually a cloud user or tenant who shares the same cloud infrastructure with other users. Since the attacker already possesses legitimate credentials, they may misuse cloud resources more easily. These attackers may exploit weak authentication systems, misuse confidential information, send spam emails, crack encryption, or even launch denial of service attacks using cloud resources themselves. Since the attack comes from within the trusted boundary of the cloud, prevention and detection becomes much more challenging. That is why trusted attackers are also called malicious tenants in cloud environments. Among all threat agents, malicious insiders are considered one of the most dangerous. The reason is simple. These attackers are already part of the organization or connected to the cloud provider in some way. They may be current employees, former employees, contractors, or third party staff members who have access to the cloud infrastructure. Now, think about this situation. Suppose a bank has strong security at the entrance to stop outsiders. But what happens if an employee working inside the bank itself misuses their access privileges? That employee already knows how the system works, where the sensitive data is stored, and how security mechanisms operate. So the damage potentially becomes much higher. Exactly the same thing happens in cloud computing. A malicious insider may possess administrative privileges allowing access to important cloud resources, customer data, or management systems. Because they already have authorized access, their actions may initially appear legitimate, making detection very difficult. For example, an unhappy employee may steal confidential customer information, modify cloud configurations, leak sensitive company data, or intentionally disrupt services. This slide also shows a workstation symbol with a lightning bolt. This symbol simply represents that the attack was initiated by a human using a computer system. It does not point to any specific attacker type but generally indicates a human driven attack. So, overall, malicious insiders are highly dangerous because the threat comes from within the trusted environment itself. After understanding different types of threat agents, Let us now move to the major cloud security threats. This slide gives an overview of the important attacks and security issues commonly seen in cloud environments. These threats mainly target data confidentiality, integrity, availability, and access control within the cloud system. In the next few slides, we will discuss each of these threats one by one in detail and understand how each one affect the cloud services and users. Let us now discuss the first cloud security threat called traffic eavesdropping. In cloud computing, data continuously travels between users and cloud services through networks. During this communication, if an attacker secretly listens to or captures the transmitted data, it is called traffic eavesdropping. This attack is usually passive, meaning the attacker silently monitors the communication without immediately changing anything. Because of this, the attack may continue for a long time without being detected. Now, consider a real life situation. Suppose two people are having a private conversation in a public place and someone nearby secretly listens to the discussion without their knowledge. That is similar to traffic eavesdropping. In cloud environments, attackers may capture usernames, passwords, banking details, confidential documents, or sensitive business information. The diagram on the slide shows that the cloud user sends a message to the cloud service, but in between, a malicious service agent intercepts the communication and makes an unauthorized copy of the message before forwarding it normally. So the communication appears normal to the sender and receiver, but confidential information is already exposed to the attacker. This threat mainly affects confidentiality of cloud communication. To prevent such attacks, cloud systems commonly use encryption techniques so that even if attackers intercept the data, they cannot understand the actual contents. Now, let us discuss another important cloud security threat called the malicious intermediary attack. This attack is more dangerous than traffic eavesdropping. In traffic eavesdropping, the attacker only listens to the communication. But here, the attacker not only intercepts the message but also modifies it before sending it to the destination. Now imagine the situation. Suppose you send an important document to a friend through a delivery person. While the document is being delivered, someone opens it, changes some information inside, and then sends it forward as if nothing happened. Your friend receives the document believing it is original, but actually the contents were altered during transmission. That is exactly what happens in a malicious intermediary attack. In cloud communication, the malicious service agent secretly positions itself between the cloud user and the cloud service. The attacker may change message contents, insert harmful data, modify requests, or inject malicious code into the communication. Now, look at the diagram shown. The cloud service consumer sends a message toward the cloud service. The malicious service agent intercepts the message, modifies it, and then forwards the altered message to the virtual server. As a result, the virtual server processes harmful or fake information without realizing the message was tampered with. This attack mainly affects confidentiality, integrity, and sometimes even availability of cloud services. To defend against such attacks, cloud systems use encryption, digital signatures, and secure authentication mechanisms. Now, let us discuss one of the most common cloud security threats called the denial of service attack, or DOS attack. The main objective of this attack is to make cloud services unavailable to the users. Now think about a busy highway. Normally vehicles move smoothly because traffic is controlled. But imagine thousands of unnecessary vehicles suddenly enter the road and block the entire traffic flow. Genuine travelers become stuck and cannot reach their destination. Similarly, in a DOS attack, attackers flood cloud servers with huge numbers of fake requests or excessive traffic. As a result, server resources becomes overloaded, system performance slows down, and genuine users cannot access the cloud service properly. In cloud computing, this problem becomes more serious because multiple virtual machines may share the same physical server. Now, look at the diagram shown here. Cloud service consumer A continuously sends multiple requests to the cloud service hosted on virtual server A. Because of the excessive workload, the underlying physical server becomes overloaded. As a result, not only virtual server A but also neighboring virtual machines like virtual server B gets affected. So even users such as cloud service consumer B become unable to access cloud services. This shows how one attack in a shared cloud environment can affect multiple users together. Next is insufficient authorization. This attack occurs when a user gets access to resources that they are not actually supposed to access. In simple words, the system gives more permissions than necessary. Now imagine a college lab. Normally, students may only have permission to use systems inside the lab. But suppose one student somewhere gains access to the staff room or confidential record section. That means authorization control has failed. Similarly, in cloud computing, some applications or databases are designed assuming that only trusted users or programs will access them. But if attackers bypass access restrictions, they may directly access protected cloud resources. Now, look at the diagram shown in the slide. Cloud service consumer A directly accessed the database even though the database was originally intended to be accessed only through a secure web service used by cloud service consumer B. This means the attacker bypasses the intended access path and gains unauthorized access to sensitive information. The slide also explains another variation called weak authentication. Weak authentication happens when cloud systems are protected using weak passwords or shared user accounts. Now, imagine a classroom where everyone knows the same cupboard password. Even though the cupboard is supposed to be secure, anyone who knows the password can open it easily. Similarly, in cloud environments, if users keep very simple passwords or if multiple users share the same account credentials, attackers can easily gain unauthorized access. For example, passwords like 1234 password or usernames with birth dates can often be guessed or cracked very quickly. Now, look at the diagram shown in this slide. The attacker successfully cracks the weak password of cloud service consumer A. After obtaining the credentials, the attacker creates a malicious cloud service consumer that behaves exactly like the legitimate user. Since the cloud system believes the attacker is an authorized user, access is granted to the cloud-based virtual server. The dangerous part here is that the attacker may gain access to a large number of cloud resources depending on the privileges of the compromised account. So, weak authentication can lead to serious security breaches in cloud environments. Now, let us discuss virtualization attack. Cloud computing mainly depends on virtualization, where multiple virtual machines share the same physical hardware through a hypervisor. Think of it like multiple apartments inside the same building. Even though each family lives separately, all apartments still depend on the same building structure. If someone damages the main electrical system or central control area of the building, all apartments may get affected. Similarly, in cloud computing, multiple virtual machines share the same physical server. Now look at the diagram shown here. An authorized cloud service consumer gains administrative access to a virtual server and then misuses that access to attack the underlying hardware or virtualization platform. If the attack succeeds, other virtual machines running on the same physical server may also become vulnerable. So even though virtual machines appear isolated, attacks on the virtualization layer can affect multiple cloud users together. Now let us discuss another important cloud security threat called overlapping trust boundaries. In cloud computing, multiple users often share the same physical infrastructure. Because of the shared environment, the trust boundaries of different users may overlap. Think of it like several families living in the same apartment building. Even though each family has separate apartments, they still share common facilities like elevators, water supply, parking areas, and power systems. If one resident intentionally damages shared facilities, other residences may also get affected. Similarly, in cloud environments, one malicious cloud consumer may target shared resources with the intention of affecting other users sharing the same infrastructure. Now look at the diagram. Cloud service consumer A is trusted by the cloud provider and gets access to a virtual server. But instead of using the resources properly, the attacker uses that access to attack the underlying physical server and the virtual server used by cloud service consumer B. So even though consumer B is not directly attacked initially, the shared trust boundary causes the impact to spread to other users also. With this, we come to the end of the part 1 of cloud security. In the next part, we will be continuing about the cloud security mechanisms. Thank you.